Hi, this is Francesco, and the problem that I had most trouble with in the last Physics 2 test was the second problem about a particular diatomic molecule that consists of a positive ion with charge plus E and a negative ion with charge minus E separated by a distance 1.5 times 10 to negative 10 meters, as shown in the diagram. Locations 1, 2, and 3, and 4 are shown in the diagram. So first question was, location 1 is 2 times 10 to the negative 8 meters from the center of the molecule, and location 2 is 3.10 to the negative 8 meters from the center of the molecule. Calculate the potential difference V2 minus V1. Show all steps in your work. So now, in order to calculate all of this, you have to think about the main principle of voltage behind, which is V2 minus V1 is equal to minus the integral from position 1 to position 2 equals to E, the electric field from the dipole, times dl. And both of them are cross-multiplied as vectors. So now, if we want to convert all of this, you will get that first you have to determine the electric field, which is E21 is equal to 1 over 4 pi epsilon naught 2qs over r cubed, which is the standard formula of a dipole, times the unit vector 1, 0, 0. Then, when you think about it, since only the x direction is the same, you can write up the integral in terms of the x components. P1 x, P2 x, 1, 4 pi epsilon naught 2qs r cubed dr, because dl will be equal to dr 0, 0, since it's going to be all into the x components. So now, since the first position is 2 times 8 to the negative 8, and the second position is 5 times 10 to the negative 8 meters, you can write it up all as minus 1/4 pi epsilon naught 2qs. That's because those will not change within the integral, times the integral with upper bound 10 to the 5 times 10 to the negative 8, and lower bound 2 times 10 to the negative 8. And so it's going to be dr over r cubed, which I put it equal to the whole integral, that after you integrate it, when you substitute all the values, minus 10 times to the negative 9 times 2 E, because it's the electric constant, S, which is the small distance between this and this atom, which then would be 1.5 times 10 to the negative 10 and you get these values that after you integrate them, you shall get minus 1.81 times 10 to the negative 3 newtons per meters per coulombs, which is minus 1.81 times 10 to the negative 3 volts. Now, is it fulfilling our expectations? So now, the position that we start from goes from here to here. So L has this direction. Now, the electric field, which will be on axis, and since it has a plus sign, also goes in this direction. So now, since the voltage is equal to, the change in voltage is equal to minus E dot L, since both of them have the same direction, this dot product alone should give you a positive value. But because of the minus in front, we're expecting to get negative voltage. And so this is how you define the first part. The second part instead is pretty tricky because location 3 is 2 times 10 to the negative 8 from the center of the molecule, and location 4 is 3 times 10 to the negative 8 meters from the center of the molecule, and calculate the potential difference V4 minus V3 and show all the steps in your work. Now, you might think, well, I can just do the same procedure that I applied here. But now, let us first see the directions of the vectors that are supposed to be dot product. The first vector is the electric field. And the electric field, since it is perpendicular, off axis and perpendicular, would be pointing towards here. Now, the vector of the length of the path, which is done by of the path of the voltage due to the electric field from this dipole, has instead, since it's from 3 to 4, this direction. Now, don't you notice that those two are perpendicular? And what is the cross product of two perpendicular vectors? Well, it is 0. So now, let us say E is perpendicular to L. Therefore, V4 minus V3, which is equal to minus the integral of E dot dl, is going to be the value of 0, since these two vectors are perpendicular. Now, part C is calculate the potential difference V4 minus V infinity and show all steps in the work. And this was where I had some problems with. Now, so we have to determine the voltage from here, from like very, very far away, far away, to here. Now, the way we do is, we know that the voltage at infinity will be 0. And because of path independence, and so you can choose that V infinity y is equal to V infinity equals to 0. Because you know that the voltage is path independent. Now, so this will imply the following, that V4 minus V infinity is equal to V4 minus V infinity y plus V infinity at y minus V infinity. And since this is equal to 0, then we can just work out the same old integral that we've been working on. So V4 minus V infinity y is equal to minus Py P infinity y E dl, and so E will be the electric field 1 over 4 pi epsilon qs over L cubed 1 0 0. dl will be equal to dl 0 1 0. So now we can just work it out as only into the y direction. Now we know that the path will be from V4 to V0, from infinity to 4, will be the vector, the direction vector will be 1 0 0. So now we shall multiply the electric field by dl while integrating. But since these two, they result as perpendicular, the result of the voltage from V4 minus V infinity will be equal to 0. And so the main trick here is to have a really good visualization of the situation. And although infinity in this case might throw you off, if you just think about it, like, what are the parameters that take into account? Is the path perpendicular to the electric field? And how does it behave with respect to that? And this is how you understand it. Thank you for watching this review.